Greetings 109 students. I'm making this one to help you out with 5 through 9 on your Unit 4 homework. So let's see, red light has a wavelength of 700 nanometers, give or take. Nano means 10 to the minus 9th, so that's 700 times 10 to the minus 9th meters. Calculate the frequency of red light. Now, for all waves, right, this equation is true. Velocity is frequency times wavelength, right? That's true for all waves, whether it's sound waves, water waves, or in this case, electromagnetic waves. Now, electromagnetic waves all travel at the same rate, what we call c, the speed of light, which is 3 times 10 to the 8th meter per second. This is true of all EM radiation. So this equation, if I rewrite it, c is equal to frequency times the wavelength. So this equation right here is how you go back and forth between frequency and wavelength. So the wavelength is the 700 nanometers, that's this. And c is 3 times 10 to the 8th meter per second. That's how you calculate the frequency. Okay, let's chat about number 6. Virtually the same problem. Done pretty much exactly the same way, it's just a different wavelength. Okay, number 7, let's see, with a strong enough laser, a person can point it at the, the moon, that's what that was supposed to be, moon, I'll have to change that. And record the time for the return signal. Let's see, look up the distance between the, it must have been the spell checker that did this, because there's no way I did that twice, but look up the distance between the Earth and the moon. And then this is just a speed is distance over time problem. And for the speed, you're going to use the speed of light, 3 times 10 to the 8th meter per second. Once you look up the distance, keep in mind that the laser has to go to the moon and back again. So you're going to have to take that into account here. Now, the rest of this is a conceptual question here. Let's see, this is how long will it take red light. The next part, how long would it take blue light? That's kind of a conceptual question. I want you to think about that and then explain your answer. I'm not going to give that answer to you. Okay, number 8, what is the frequency of radiation with a 2-meter wavelength? So again, for EM radiation, C is equal to F times the wavelength, lambda. They're asking for the frequency. The speed of light is the 3 times 10 to the 8th meter per second, and the wavelength is given in the problem. Now, once you look up a frequency, or once you have the frequency, actually, and or the wavelength, you should be able to look up the electromagnetic spectrum and classify it. Is this an X-ray, or is this blue light, or is this a radio wave? So, and I'll leave that for you to do. All right, number 9. Let's see, what is the frequency of radiation of a 2 micrometer wavelength? Micro means 10 to the minus 6. So this is a wavelength of 2 times 10 to the minus 6 meters. And again, you're going to use the same formula here to calculate the frequency. And I guess while I have it here, number 10, virtually the same thing, same formula. C is equal to frequency times wavelength. The wavelength here is given. This 2 nanometer is a wavelength. And nano means 10 to the minus 9th. And again, look it up on the EM electromagnetic spectrum and classify it. So I hope that this video helps you get through those problems. Have a great day.